Alright, hey, what's up guys? It's Bob from Code Bros, and we're going to be going over top interview questions, the medium set, arrays and strings, question number 3, group anagrams. Given an array of strings, group the anagrams together, and the answer can be in any order, where an anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So in layman terms, basically you want to see which words can be rearranged to another. So eat can be rearranged to eight, can be rearranged to tan. No, not tan, T. And tan can be rearranged to nat. So the same number of occurrences of each letter. And you want to group these together and return it. And we have some constraints. The string's length is less than 10 to the power 4. The length of each string is less than 100, which is where this is the array of strings. And it only consists of lowercase English letters. So first thing you think about when you see that it only consists of lowercase English letters is maybe you can make an array of 26 values for every single string. This is the most naive solution. Every single string, and then count the amount of occurrences for each letter and compare those arrays. So this is extremely inefficient in terms of space and time. So the next idea is that you look at these strings and you realize that they're just rearranging themselves to get the next value. So EAT you can rearrange to get ATE. Now what comes to mind is how can you arrange these values so that these strings so that they all get to the same base string. So the main idea is to sort each string. So if you sort each string, you can store them in a hash map where the sorted string would be the key and the values would be the list of strings, which are the words that you see. So EAT sorts to AET because in AXI, A is less than E is less than T. It goes in alphabetical order. Same with T and same with 8. So they can all be sorted to AET. Tan and Nat both sort to ANT, and Bat sorts to ABT. So using this method of sorting the strings, we can cut down on the space complexity by a bunch. It's a much more efficient solution. So the space complexity now is O of n because n is the amount of strings that we want to store, supposedly. So the hash map would have at most n entries, excluding keys sometimes because keys are their own. But the space complexity would be O of n. And the time complexity would be taken by first iterating through all the strings, and there's n strings, so that would take O of n. And for each of those strings, you have to sort them. And let's say the longest string has a length of k. And the worst case scenario is they all have a length of k. Sorting an array would take time O of k log k. So sorting that string would take O of k log k. And hash map searches happen in O of 1, so that's great. It doesn't really affect the time complexity. So the time complexity overall is O of n times k log k, where n is the number of strings and k is the length of the longest string. So now that we have an idea down on how to do it, we can actually start coding up the solution. And just to clarify, this is how it works. AET becomes AET, AET, and it gets added to the list of strings, which is the hash map value. Then you see T also sorts to here, add to hash map values. Tan doesn't sort to AET, add a new key, and add it in as a value of a list of strings. 8 so also sorts to AET, added in nat, ant, added in bat, doesn't sort to AET, doesn't sort to ANT, sorts to ABT. So you add it in, then you iterate over this hash map and all the values to get a list of strings, which stores the anagrams of all the strings. So let's start coding up a solution. First thing we want to point out is our return type. We call it anything. Let's call it group anagrams return list. Array list. Next, we want to make a hash map to store our sorted strings and list strings. So hash map string and list string. Call it a string map. All right, so now that we have this, we can iterate through each string. So for int I is equal to 0, So when we iterate through all these strings, the first thing we want to do is sort it and then compare it to values in the hash map, or not values, keys in the hash map. So you want to take each and sort it. So let's make this easier on ourselves. Let's convert it to a char array first. Temp char is equal to new is equal to, it's actually a nice little function for us. Strings I dot to char array. Next we want to sort this, so arrays dot sort temp char, and then you want to convert it back into a string. So string sorted string is equal to new string and temp char. This is in a for loop. Maybe you should move this out. And all right, cool. So now that we have the sorted string, we can check if it's in the hash map. So string map contains key. We have our one case, and then let's also write out our else case. So if it contains a key, all you have to take is the list of strings that has its value and add the current string that you're looking at. So string map dot get sorted strings dot add strings I. That's nice and easy. So this is the case where it doesn't store the string. So map has key sorted string. This is the other case where map doesn't. So what does that mean? You just have to add it in. So let's make a list of string temp is equal to new. And let's add onto our temp list the word that we're currently looking at. Then add this to our map. The dot put command. So we want to add our sorted string along with our array, or list, my mistake. And from there, we're almost done. Right now, what we have is we have this hash map. So now we just have to iterate through this entire hash map keys and get the values and add to the list, which is our return list declared above. So for string key in, I think it's dot key. Set GA return list dot add string map dot get key. And this is really important because we're using the fact that the return array can be in any order. So we can use hash maps. It doesn't have to be an in order system. And then lastly, we just return this value. Now let me check my code for any issues. Okay, it looks good. Before I was having the issue that I wasn't storing the string correctly. Okay, but now it's fixed. So before I was converting this char array back into a string using char array.toString, but that's not defined for char array. So we have to use this new string temp char. So the expected initial test case passed. And although it's a different order, it's the same answer. So let's try submitting. Okay, so our solution was accepted. That's great. As always, the code is in the description, the GitHub link. If you have any suggestions on future videos or any concerns or anything at all that you want to say, leave in the comments or contact me. Thanks for watching.